1 plus 2 equals to 3. 2 plus 2 equals to 4. If you have one apple and you have another apple, then you have two apples. Like, this is how mathematics works. No one is going to argue with you that 1 plus 2 equals to 4 or 1 plus 2 equals to 5, and no one's going to debate about that. I mean, like, this is something very, very obvious. And math is all good until you start playing with powers and multiplication that you see, like something strange begins to happen. And by playing, I mean, let's say you take 2 multiplied by 2 multiplied by 2, which equals to 8. Everyone knows it equals to 8. Now, because there are three 2's which multiply with each other to give 8, we can also write this as. Similarly, we know that 2 multiplied by 2 equals to 4. So we can also write this as. And the same is true for any other number. The same pattern is for any other number layer. Now things will start to get a little bit weird. Now I ask you, hey, what happens if I raise any number to power 0? And at first, if you are new to this like me, you will get blank. But I figured it out by this way. First, I wrote 5 raised to power 3. Then I wrote 5 raised to power 2 below it. And then below it, I wrote 5 raised to power 1. And then I wrote 5 raised to power 0. Now, I noticed a pattern here. Like if you have like 5 raised to power 3, which technically means three fives are multiplying with themselves, which equals 125. So, and the same way, if you look at 5 raised to power 2, which means two fives are multiplying by themselves, and which equals 25, then you notice like if you have to go from 125 to 25, you have to divide by 5. Okay, like you can go to like 5 raised to power 2 from 5 raised to power 3 by dividing by 5. And I mean, like if you divide 125 by 5, you reach 25. If you divide 25 by 5, then you reach 5. So this technically means if you have to go down one step more, you have to divide 5 by again 5. And thus, that 5 raised to power 0 equals to 1. Then I tried to find answer for 0 raised to power 0 by this method, but I could not do. You see, like if you wrote like again on the same pattern, if you wrote everything like you did for 5 raised to powers, like you will again see, like if you have 0 raised to power 3, and then which means three zeros are multiplying by themselves, and I have to go to 0 raised to power 2, then I have to divide by 0. But technically, if I divide by 0, okay, like from any 0, if I divide by 0, the 0 divided by 0 gives infinity. And like, and 0 multiplied by, then we have left with 0 multiplied by infinity, which is still infinity. And yeah, and it is undefined too. But yeah, you cannot, I mean, in short, you cannot apply the other method what we used for 5 raised to powers and to 0 raised to powers. Okay, we cannot do this method. So 0 is like doing this strange behavior, showing this strange behavior. Like you cannot calculate this by this method. And like, first of all, this is weird. That so how do you find 0 to the power 0? I mean, that's the main question. Now these are the moments when you were taught maths in school and college, and you thought it is boring and it is of no use. And then you start playing with basic maths and realize how much cool some of the useless math really is. Take, for example, binomial theorem. I was taught by my math teacher that it is used to expand algebraic expressions, but he never told me that the machinery behind the binomial theorem can help me answer an impossible question, like what is the answer to 0 raised to power 0, which I cannot get from basic arithmetic. Now, when you use the weapon of binomial theorem on this 0 to the power 0, it does give an answer, and the answer is 1. So, ta-da! Now we know what the answer to 0 raised to power 0 is. But if it was that simple, then I will not be making this video on this topic. And things starts to get weird from here on, okay? Now, when you go to higher classes, you study something called calculus. And in calculus, there is a very powerful idea called limits, which kind of also helps you find answer to unsolvable things. In this case, when we apply the concept of limit to our problem, real weird stuff starts to happen. Now we're going to use this limit to get our answer, and the answer becomes 0. Like, to the same question which the binomial theorem was telling us the answer is 1, this this limit concept is telling us that no, the actually the answer is 0. And now this is getting puzzling. And like, and when you and the most crazy part is, like, when you try to find a limit from a different direction, and when you try to solve it from just a different direction, the answer of the limit becomes infinity. I mean, like, yeah, I mean, like, now we have three different answers which are equally valid. And like, and it gets more crazier when you try to solve the same thing using a different function. I mean, like, the answer then becomes 1. Now you have three different answers for the same thing, which I guess which is the most weird thing about maths, because it's just like you can get the idea of how crazy it is by this. Imagine if 1 plus 2 equals to 3, but also it's 1 plus 2 equals to infinity, and 1 plus 2 also equal to 0 at the same times, and they all were mathematically valid and correct. Math do not behave like this. That is why 0 to the power 0 is the most strange number in all of mathematics. Maybe there's something about 0. Maybe there's a reason to it that we do not know yet. Until then, remember that the world is full of things to explore.